Okay, this video is the third one for a review, even though it's titled review number one. I wanted to practice the log stuff before we got into the compound interest. All right, so on this one, we want to figure out the equation, and notice in the directions I tell you that no fancy calculations are required. Okay, so don't put this into the stat menu. You don't need to. Remember, the equation that we're trying to use is y equals a times b to the x. And our growth or decay factor is always our b. Our initial value is the a. So the initial value is what it is at time 0. That's easy to find. The growth or decay factor is found by taking the second value, 9.6, and dividing it by the first. So if we do 9.6 divided by 8, we get 1.2. So this is 1.2. So my equation is going to be y equals 8. Now you can use a dot for times, but recently I found if I put it in parentheses, it seems a little easier to read. But if you use the dot, it is still equally correct. Okay, now we're dealing with a real life application and we have a table. Now on number 1, we didn't have to use our calculator because we had the initial value. We do have the initial value here on this problem, so technically we could do it without a calculator, but the one on the test does not have the initial value at time 0, so you're going to have no choice to put it into the calculator. So I want to practice the calculator portion of this because that's really important. Okay, so let's go to the calculator. To enter it, we're going to go to the stat menu, and you need to go to edit. I've already put the values in here, so you can do that on your own. But remember, if you want to clear out a whole column, you're going to put your cursor on the very top and hit clear and down arrow, and that clears out the entire column. But I'm not going to clear them out because these are the values that we want. So I've got my X's in L1 and my Y's in L2. Once I'm done with that, I'm going to hit the stat menu again, and now I need to do a calculation. And if you scroll up, the one I want is exponential regression, which is choice 0. So you can scroll and hit that one, or you can just hit 0. And there you go. So our X's are in L1, our Y's are in L2, and we go down and hit calculate. And you'll notice at the top, it gives you the equation again, which is exactly what we want. And now we're going to use these numbers for our A and our B, and we're going to round to the nearest hundred. So the first value, A, is, can't use an eraser, 29.98. And our B is 1.9. So my equation, just like we did up above, this already has the y equals. That one didn't, so I had to write it. This one, I got it for you. So we have 29.98 times 1.9 to the x. Again, if you want to use the dot, that's okay too. So now we need to predict the population in 6 years. So our chart just goes to 5, so we need to figure out 6. So we're going to put 6 into x and solve. So we're going to do 29.98 times 1.9 to the 6th power. So let's put that in our calculator. So we're going to do 29.98 times 1.9 raised to the 6th power. And then we hit enter, and there's our number. Now this is talking about trees. So we want to round to the nearest whole number because we're not going to count partial trees. So this would be 1410. So we're going to say 1410 trees. Okay, then it says the example of growth or decay. Oh, goodness gracious. This is not trees. I wasn't reading the problem. This one is about elk. Okay, again, you don't want a partial elk. Is this an example of growth or decay? Well, the number is getting larger as we go, so that is going to be growth. Okay, and then our decay factor is always our B, which is 1.9. So there's nothing to calculate because you already did the calculations. Those match. B does represent your growth factor. Okay, let's try some of these compound interests. What's important is that you pay attention to how often it's compounded. It says monthly, quarterly, semi-annually, we're using this equation. But if they change the word and say continuously, then you've got to use the equation with an E. That's how you know the difference. Okay, so in the first one, well, in all of them, we're investing $4,600. What you invest is always your P. Your percent, that is going to be your rate, but we have to have it as a decimal. So you got to move the decimal over 2 places. Okay, so it's going to be 0.035. Okay, how many years it's in is your time. How often it's compounded, this is your N. And if it's monthly, it's going to be 12. So now that I have the facts, I'm going to write my equation and the answer because that's what it's going to ask you to do on the test. And if you don't have both, you're not going to get full credit. So because it's compounded monthly, I know I need to use my yellow equation. So I'm going to have P, which is 4,600 times 1 plus my rate, which is 0.05, or excuse me, 0.035 over N, which is the number it's compounded, which is 12, times 12 times 15. And we're going to take that equation and put it into our calculator. Okay, so let's go to our calculator and clear this out just so we're not confused by anything. So I'm going to do 4,600 parentheses 1 plus, and then to get our fraction, we're going to do alpha y equals. Option 1 is numerator over denominator. So we have 0.035 over 12 is our n. Get out of the fraction, close your parentheses, and then the exponents, we're going to have 12 times 15. And then hit enter. Now this is money. Money, I'm not going to tell you. You should know on money, you round to the nearest hundredth. On your quiz, I didn't count off if you rounded incorrectly or if you didn't round to the right place value. I will absolutely count off on the test if you do not round correctly. We need to learn how to round. So 7,700, 770 or 7770. That's a lot of sevens, 0.17. Okay. $7,770.17. Ooh, okay. Now, the next one, everything stays the same, except now it's compounded quarterly. And how often it compounds, that is your N. So now our N changes to quarterly, which would be 4 times. Everything else is still the same. Whoops. So when I write my equation, it's going to be 4,600 times 1 plus 0.035 over, this time N is now 4 times 4 to the 15. Okay, so now I'm going to go back to my calculator. Instead of retyping that, I'm going to hit second enter. And I'm going to arrow to the right and put my cursor over here, and I'm going to get the 4. Well, now it says 42. I don't want that 2. So I'm going to hit this delete button up here. That makes the 2 go away. And now I'm going to keep arrowing to the left. I said right earlier, but you know what I mean. Okay, so here's my 4. Hit the delete on the 2. Now my equation is correct. And now I can write that. 7758.37. Okay. When it's money, I'm going to expect you to label it as money. Okay. I'm going to expect you to round correctly to the nearest hundredth. Now, on the last one, it changes the word to continuously. And when it's continuously, you now need to use the equation with the E. Also, a side note, just like the quiz, the equations will be given to you. You just need to use them correctly. All right, so it wants P. P is the initial investment, which is 4,600 times E times the rate, which is 0.035 times T, which is time, which is still 15 years. And that's the equation that we're going to put into our calculator. So we're going to do 4,600. Now, I have told you, and it's absolutely correct, that E is above the division sign. You can use that, or just as an option, neither one is better than the other. You just giving you options. If you notice above the natural log, it says e to the x in blue. So if we do second natural log, it already puts that exponent up for you. I mean, it saves you a click. It's not super helpful, but there you go. You got options. So this gives you 0.035 times t, which is 15. And now we get 776.11. Oops, I'm off of 7. There we go. Now, this is what we did. I want to take this and combine it with our log material and see if we can put the two things together and bring it full circle. So this we haven't done before, but I think we can try it. So it says we invest $2,000. Well, that's what we invest, that has to be our P. And an account that has a 2% interest rate. Well, that's obviously my rate, but I need it as a decimal, so it's going to be 0.02. It compounds continuously. That means I need to use my E equation. How long, that's time, will your money, to have to leave your money invested to reach $3,000. So that is our A, our final value. Okay, so that's a little bit different. Normally we're solving for A. This time we're solving for T, but I feel confident we can do it. Let's put our values in. So I'm going to do 3,000 equals P, which is 2,000 times E to the rate 0.02 times time. Okay, well, I can't quite put this in like this, so I got to try and simplify it a little bit more. So I'm going to divide both sides by 2,000 so I can simplify my equation. Well, I can leave it like this, but oh my gosh, that's ridiculous. Let's just leave it as 3/2 equals E to the 0.02 T. Oh, we actually know how to do this because if we're solving for an exponent, we can use a log. So I can rewrite this as log base E, which is really the natural log. So I can say the natural log of 3/2 equals 0.02 times T. Oh, we still know how to do this. What am I going to do now? I'm going to divide by 0.02. Oops. Okay, now I need to put that into my calculator. So I'm going to put in here, let's clear this out so we can do it. I've got, let's help our calculator out. Well, no, we're good. Okay, so we're going to do the natural log, and now we need 3 divided by 2. That's my parentheses. And then all of that, if you remember, is divided by 0.02. And then I hit enter. There's my answer. Let's round to the nearest hundredth. And remember, we're solving for time. So this isn't money anymore. The time is in years. So this is 20.27 years. Okay, let's try this again. This time we invest $1,800. That's our principal. Here is our rate of 0.025. It compounds continuously. So when it uses continuously, we know we have to use the equation with an E. How long, that is our time in years, money invested to reach 2,400. That is our final value. So just like the one before, we are solving for the time and not for the final value. So let's plug it in and see what we can do. Okay, so we are going to end with 2,400 equals, we're starting with 1,800 times E raised to the rate 0.025 times time. So let's do just what we did over here. We're going to divide by 1,800. Okay, those cancel. How are we going to reduce that? Well, 24 and 18, I can divide by 6. So, oh dear, here it goes again. Divide by 6, so this is going to be 4. 18 divided by 6 is 3. So this gives me 4/3 equals E times 0.025 T. Okay, we can do this, rewrite it. So we have log base E, which is the natural log of 4/3 equals 0.025 times T. So to get our final answer, we're going to divide by 0.025. We have definitely done this before when we're dealing with logs. We can continue to do it. Okay, so now in our calculator, we're going to have the natural log of 4 divided by 3. Close your parentheses, and then we have to divide this by our rate, which is 0.025. So we have 0.025 and hit enter. In this case, it's going to take us 11.51 years. So just about 11 and a half years. So T is going to be 11.5, what did I say, 1 years. Okay. One last one. You invest 1,500. That's going to be your P. Your rate is 0.035. It compounds quarterly. When it gives you quarterly, that is your N. And the only equation that uses your N, oops, not equals, is P times 1 plus the rate over N times the rate times time. Okay. And again, just like here, you're going to get the equation. Oh, I didn't mean rate. I meant N times T. There you go. Okay. Let's see how long, that's going to be time, do you leave your money invested to reach $3,000? That's your final value, which is your A. So let's plug this in. So we're going to do 3,000 equals 1,500 times 1 plus our rate, 0.035, times the number of compounding sections, which is 4 because it's quarterly, okay, times N, which is 4, times T, which is time. Okay, just like we did in the last ones, we're going to start by dividing by 1,500. So let's divide by 1,500. 3,000 divided by 1,500 is 2. So we get 2 equals 1. Why do I keep putting a decimal point there? That's not what I meant. 1 plus 0.035 over 4 times 14. Okay. We could work with this, but for some of you, that might get a little overwhelming and confusing. So what I'm going to do is convert this part to a decimal so it's a little bit easier to work with and manipulate. So let's put just that part in blue into our calculator. So we're going to have 1 plus 0.0, that alpha y equals 0.035 all over 4. And now we've got a decimal, 1.00875. Okay, so now I'm going to rewrite it. So I have 2 equals 1.00875 raised to the 4t power. Okay, now we're going to rewrite it. This is the base, the 1 point something is the base of my exponent. So that means I'm going to have log base 1.00875 of 2 equals 4t. And then to solve, we need to divide by 4. Well, if that isn't weird, I don't know what is, but we can absolutely do this. Let's try putting this in our calculator. So we need to go to the math menu, and we need to go to option A, and I'm going to do log. Now this is my weird decimal, base 1.00875 of 2 out of that, and then to that whole thing, we need to divide it by the 4. Well, we did this a million times. We just didn't have weird decimals there, but your calculator's doing it. It's not stressful to type the numbers. So we hit enter, and there's our answer, 19.89 years. So our final answer, oops, is time equals 19.89 years. Okay. Now, because this was only on the review day, okay, I don't want you to stress about it, but This is a skill and an application that we're going to need for coming years. And you have all of these things together. You have the ability to do these problems. So that's why I want you to be prepared for it.